Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is a vicinal 1,2-diaryl compound. C1 has CH3, pH, and H substituents. C2 has pH, Br, and CH3 substituents. So the full structure is pH, CH3, H, C1, C2, pH, CH3, Br, I, 1,2-diphenyl 1,2-dimethyl 1-bromo. Wait, let me reread. C1 has CH3, pH, H attached, and bond to C2. C2 has pH, Br, CH3 attached, and bond to C1. So the compound is C1, pH, CH3, H, C2, pH, Br, CH3. Moving on to the next step. E2 requires antiperiplanar arrangement of H and Br. The base, AlC. KOH abstracts a beta hydrogen anti to the leaving group, Br on C2. The H must be on C1, the carbon adjacent to CBr. C1 has only one H available. Moving on to the next step. The only available beta H is on C1, since C1 bears one H. So elimination occurs between H on C1 and Br on C2, forming a double bond between C1 and C2. And for the final step, removing H from C1 and Br from C2 gives C1 pH CH3 is equal to C2 pH CH3. This is 1,2-diphenyl 1,2-dimethylethylene, or EZ pH CH3C is equal to CpH CH3 I. Both carbons of the double bond each bear one pH and one CH3 group. A. pH to C is equal to C, CH3. 2. Left carbon has to pH, right has to CH3. This would require loss of a methyl or rearrangement, not consistent. B. pH, CH3. C is equal to C, pH, CH3. Left carbon has pH and CH3. Right carbon has pH and CH3. This matches C1, pH, CH3 is equal to C2, pH, CH3. This appears identical to option C. C, CH3, pH, C is equal to C, pH, CH3. Same connectivity as B. Left carbon has CH3 and pH, right carbon has pH and CH3. This is the same alkene as B, written differently, or represents a specific geometric isomer. Since there is only one type of beta H, on C1, only one elimination product is possible, CH3, pH, C is equal to C, pH, CH3. This corresponds to option C, and structurally, B. But the answer given is C. A. pH to C is equal to C, CH3. 2 would require migration of groups, not an E2 product. B and C appear structurally similar, but option C correctly represents the geometry connectivity of the product from antiperiplanar E2 elimination with the given stereochemistry. D is a substitution addition product, not elimination. Therefore, the correct answer is C. Therefore, the correct answer is option C.